Previously, we found these slope values, and as a reminder, the slope of a position time graph is equal to the velocity. So each of these values that we have written along this position time graph, well, this is position, sorry about that. So position represents the velocity. And so in this first segment, we are increasing by 1 meter every second. And then that is in the forward direction. And then our -2 right here, this one is indicating that we are going backwards. We turned around and started going backwards at 2 meters every second. The next thing we need to do is figure out how to translate this. So these velocities off of a position time graph and create a velocity time graph. So first thing I'm going to do is, of course, label my axes. Our velocity is in meters per second. And our x-axis here is going to be time in seconds. In this previous position time graph, we have positive and negative velocities. And notice we have positive and negative positions, and so the 0 mark is not along the bottom. We need to do the same here. We need to make sure that we have some negative spots. So I'm just going to pick a spot somewhere here in the middle and draw as straight of a line as I can. Of course, if you're doing something like this, I would definitely recommend using a ruler, but I'm writing on my screen, so I can't really do that. So this line is now going to be our 0 mark, so for 0 meters per second. And then we have negative values below and positive values above. Our time is going to be the same as in this position time graph, so we need to get to 30 seconds. It just so happens, based on this grid, that I can do each one of these tick marks down here on the x-axis is 1 second. So 1, 2, 3, 4, 5 seconds. 6, 7, 8, 9, 10, 13, 14, 15. That's a 5. There we go. 20, 25, and 30. Okay. Now we got to figure out our scale for velocity. Well, our largest value, not looking at the positives and negatives, but our largest value is a 2. So we've got a 1, 0, 2, 0, and 0.5. So let's see. What if we make each tick mark like 0.25, right? And so like this one would be negative 0.5, right? So negative 0.25, negative 0.5, negative 0.75, and then negative 1. And so this would be negative 1.5. Make this negative 2. And then negative 2.5. Negative 3. And let's do the same going up. So this is 0.5. And this is 1. 1.5. 2. 2.5. And 3. All right. So before I put any points on here, I need to talk about what a velocity time graph tells us. A velocity time graph, a VT graph, tells us how fast each second, specifically in a direction. That's where these positives and negatives come in. So let's draw it out and then we'll discuss. All right, in this first segment, we have from 0 to 5 seconds, we went positive 1. Now, since it's a straight line right here, then we know that It is a constant 1 meter per second from 0 to 5 seconds. Now that this y-axis is velocity, from 0 to 5 seconds, we're going to be going, oh, actually, let me change color here. There we go. From 0 to 5 seconds, we will be going 1 meter per second. Remember, this tells us how fast each second. At 5 seconds, we all of a sudden come to a stop. So we need to show that. After 5 seconds, we come to a stop, which is at 0, and we're there for another 5 seconds. After we stop, we then turn around and go backwards at 2 meters per second, which means negative 2 meters per second. So after we stop, we turn around and go backwards at negative 2 meters per second for 5 seconds. Then we stop again. See, it doesn't matter that it's way down here. What matters is this number right here. It's 0. And so we go back to a stop for another 5 seconds. And finally, end at the 30-second mark, going forward at 0.5. All right, so that is going forward at 0.5 for 30 seconds. I like to call this the cityscape or skyline graph. It looks like a bunch of buildings. Like you could imagine, here's the sun, and then this is a building, and then this is a building, that's a smaller building. You could imagine that these are like much, much larger buildings here, right? But it's going to look like this, where it's like a bunch of little rectangles, okay? Now, what does all of this tell us, right? What does this graph tell us? It tells us how fast we're going in each second in a direction. Well, if it is above the 0 line, this means we are moving forward. If it is behind, or if it's below the 0 line, this means we are moving backwards. So positive is moving forward, negative is moving backwards. The other thing this can tell us is, again, how fast, relatively speaking, we are going. The closer you are to this 0 mark, the slower you're going. Our fastest speed is right here at negative 2. Now, this is where math can be a little different. In math, negative 2 would be the smallest value here. In physics, we care more about the absolute value, about the number itself, not the sign. This means it's going 2 meters per second backwards. And so that value, because it's the furthest from 0, is the largest. The slowest, that is not 0, okay? The slowest would be the closest to that 0 mark, which would be this one. because this is 0.5 meters per second forward. Hopefully this helped with how to find a velocity time graph and interpret it. As always, let me know if you have any questions.